Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology, Coimbatore. So in this video, we are going to discuss about design of combinational circuits. So let us have a small recap about the previous class. So in the previous class, we discussed logic gate. It is the basic blocks of digital circuit and Boolean algebra. We use some laws to minimize the Boolean expression. For example, De Morgan's law, associative law, and some identities. And min term and max term, it is otherwise called SOP, that is sum of product and product of sum. Using this, we can write the Boolean expression of any circuit. And K-map. K-map is the another method used to simplify the Boolean expression. Let us go on to the topic. So today we are going to cover what is combinational circuit, why it is needed, that is what are the empathy points, and construction types and applications of combinational circuit. So first we should know what is combinational circuit. So combinational circuit is a digital circuit which accepts input and deliver outputs. The output depends on the present input of the circuit. It does not require any memory. So before that, we should know why it is needed. What are the empathy points? The combinational circuits are required because of its simpler design, easier operation, reduced complexity, and versatile applications. Because of these reasons, it is very much needed in digital circuits. So by collecting the empathy points, we can define the functions of combinational circuit. So the combinational circuit, the outputs depends only on current input, and it is not required any memory because it depends only on present input, and no feedback is required. It performs logical functions using logical gates, and it can create accurate, simple and efficient design. So next one is construction of combinational circuit. So we used some steps to construct the combinational circuit. The first step is, first we have to define the input and output. By analyzing the circuit specification, we can define the input and output. After that, we can list out the truth table. For example, for n inputs, we need 2 power n possible outputs. For example, if the input is 4, so we can calculate the number of possible outputs are 2 power n, that is 2 power 4, that is equal to 32 possible outputs. So the truth table lists all the possible input and output. So after the truth table, the Boolean expression can be written using SOP or POS form. After that, it has to be minimized to minimize the number of gates. So K-map can be used, Boolean algebra also used, but compared to K-map, compared to Boolean algebra, K-map is very easy to implement. After that, after reducing the Boolean expression, the logical implementation is done. So these are the steps, these are the idea to implement a combinational circuit. So there are examples of combinational circuits are adders, subtractors, multiplexers, demultiplexers, encoders, decoders, comparators and code converters. So these are the examples for combinational circuit. So the next one is applications of combinational circuit. So the main application of combinational circuit or arithmetic operation. Arithmetic operation means addition, subtraction, multiplication or the arithmetic operation, and code converters, that is BCD to ASCII, ASCII to BCD or the code conversion, and digital, and mainly used in digital systems error detection, that is it is mainly used in parity generator, and data processing, memory addressing, control systems, or the applications of some general applications of combinational circuit. Coming to real world application, it is mainly used in calculators, that is the adders and subtractors are used in calculators and digital watches, and by using logic circuits and logical control, it can be used in traffic light control system. And the main application of a combinational circuit is computer and laptops, because of it, because the computer use arithmetic and logical unit. So the arithmetic for arithmetic unit, adders and subtractors are used, and multiplexers are used to for memory selection, and the final application are elevators. So decoders and encoders are used to operate elevators or lifts. So hope this video will give you a brief introduction about the combinational circuit. Let us summarize. So in this video we saw about what is a combinational circuit, and what are the steps involved in construction of combinational circuit, and different types of combinational circuit, that is examples of combinational circuit, applications of combinational circuit. So combinational circuit output depends only on the present input, and different types are adders, subtractors, multiplexers, encoder, decoder, and different applications are calculators, watches, computers, laptops, and lifts. So let us have a small assessment. The first question is, which of the following statement about combinational circuit is true? And the next question is, which of the following is the correct sequence of steps for designing a combinational circuit? So the answer for the first question is option A, that is the output depends only on the current input. And the answer for second question is option B, that is first we have to define the problem and derive the truth table, simplify Boolean expression using SOP and POS, and final the implementation of logic circuit. So these are some references. Thank you.